Hash tables. Now imagine you have this problem. You're trying to sort the members of the LA Dodgers into an array by numerical order of their jerseys. You're immediately going to run into a problem. That being that the correspondence between each player to their number is inconsistent. It's unclear. There's nothing about Mookie Betts that necessarily equals 50. I mean, if you asked him, I'm sure he'd have an explanation. But you've no idea what numbers to expect, and you don't know, you don't want to just keep sorting them throughout your array the entire time, every time something gets added. We can solve this problem with a hash table, which uses keys, a hash function, and the array that we're storing this in. So in this case, our keys would be the names of our players, and that gets passed into a hash function, which using the player's number will pass into the array at an estimated index where we think we're not going to have to move it. And sometimes we are going to have to move it. If our hash function shoves two things into the same place with different keys, then we usually have two options. Option number one being something like linear probing, where we essentially just take whichever is bigger, in this case the jersey numbers, and shove it into the next available spot, in this case being index number 15. There's also chain hashing, which is to say instead of storing the value in the array, we store a container in our array. So in this case, we're storing the head pointers of linked lists such that these two players, who both have a number between 10 and 19, can be stored at index 1 because we have a linked list storing all numbers 10 through 19.